Alrighty, let's see what we got here. So from yesterday, there was something weird about that problem, which was that it was way too easy, and it was part 1, so apparently part 2 is today, and it's actually the actual change that I was thinking about to make it hard. Okay, so you're going to enter your nums of blank n and integer k. You must select exactly k distinct non-empty subarrays. Between L and R, subarrays may overlap, but the exact subarray, exact same subarray from L to R cannot be chosen more than once. So yesterday was like you can choose the same subarray more than once, in which case it was trivially easy in order to just choose that. Well, you can just choose the whole array. Anyways, the value of the subarray is defined as the max of the values minus the min of values. The total value is the sum of the values of all chosen subarrays. Return the maximum possible total sub value you can achieve. So here you choose 4. So you definitely want the 1, 3, and then the 1, 3, 2. That's going to give you 2 each. Max being 3, min being 1, the value being 2 for those 2 subarrays, and then 2 plus 2 is 4. And yeah, I chose 2, okay. Here you choose 3, you want the 5 and the 1, like 5, 1, 2, 5, 1, 4, 4, 2, 5, 1, so the value of those subarrays is each 4, 5 minus 1, and then times 3 is 12. Okay, so it's actually feel like this might be a little simple. Let's see where the complication arises. So what's the general algorithm here? You want to choose k subarrays. I think if you know where let's say the values are unique somehow, although they can repeat. I assume this is going to be probably n log n, possibly O of n. I don't think it's n squared in terms of algorithm. Okay, so, if you're going to choose k subarrays, let's say there's a position where the maximum and the minimum resides. You want to, and let's say somehow they're unique, then you want to use all the subarrays that include them. So general kind of process or general thinking would be find count of subarrays that include max and min. And then find count of all subarrays that include kind of either like 1 less than that, kind of like max minus 1 min, or max and min plus 1, something like that, where we're talking about orders rather than actual numbers. One less than that, and also not inclusive, not including both max and min. So that's the tricky part, I guess. Like if you have, let's say the max is 100 and the min is 1, you want to find all the subarrays that include both 100 and 1. And let's say the second highest is 99 and the second lowest is 5, so you want to find 99 to 1. That is also not including 100. So let's say the 1 and the 100 are somewhere in the array. If the 99 appears between the 1 and 100, then there would be no subarray that you could choose that would be non-overlapping. Because 99 would strictly be less than 100. So it would have to be a 99 that's kind of like after here. Actually, that's not true, is it? That's actually the reverse logic. If there's a 99 here, then that's actually fine. Because you can just go up to the 99 to 1. So if there was a 99 over here, then you'd always include the 100. Oh boy, okay. So what does this say? So the number of subarrays that include 1 to 100 would be all the subarrays that include 1 and earlier as a starting index, and 100 and later as the ending index, wherever the index of 100 is. This feels like what's that term? Asymptotic? No, not asymptotic. Something stack. What's the technique called? I think it starts with an A. Anyways, it's one where the values are strictly not ascending. What's the term? What's the term for a stack that maintains an invariant? Maintains terms for keeping a stack that is strictly increasing or decreasing. Monotonic. This feels like maybe a monotonic stack type problem. So you have a 1. You have 1 and a 99. So if you have something lower, let's say there's a 2 here, or let's say this is a 10 and there's a 1 here. So it decreases. That means 10 can no longer be the lowest, because then 1, when you include that, if it reaches back further to the front, the 1 is always low. So the 1 does hide the 10 on the stack. I wonder. Minus the min. wonder 100 how should I visualize this? So it's almost like for any given index, if you were to treat that as your end index, then what? So if I have 100 here, if my ending index is this index or afterwards, assuming 100 is the biggest number in my array, my ending index is this number or afterwards, and my starting index is this number or before, this position or before, then 100 would be the maximum. Huh. 4, 2, 5, 1. Your subarray is always going to include at least 2 elements, because if a subarray includes just 1 element, then the difference is going to be 0 and you're not contributing anything. Let's say there's the subarray is only 2 lengths. 2 lengths, you're just comparing differences between them, between every consecutive pair of elements. Interesting. Thinking of an approach that would be n squared. Thinking of an approach that would be n squared currently, which obviously just isn't going to work because n squared is going to be 25 times 10 to the 8th, which would be 2.5 billion. I wonder. For each number, I'm trying to think of how far it can extend. How far it can extend leftward and rightward as the lowest or the highest. And then somehow how far it can extend leftwards or rightwards as the lowest and the highest. So, like, if I think of where the 1 is positioned, or maybe 100. Okay, so if 100 is the biggest, then 100 could extend, you know, as far rightwards as the end of the array and as far leftwards as the start of the array as the highest. And for the low, 100 will only extend to itself on the left and right side for being the lowest of any subarray. And then for 99, 99 is biggest for all the indices up to the 100, and then like all the way to the first element, to the index 0 as the highest. I think I could generate that in O of n time. Or maybe O of n log n time. Feels like O of n. No. I could probably generate that. It's either n or O, but it's either O of n or n log n time. Probably n log n time. Anyways. But once I have that, can I, for both the high and the low, is it possible to generate the ranges where a certain subarray might have a set for the low and high? I think that might be O of n squared. Because I might be, it's either O of n. I might be needing to compare every high versus every low. Every high versus every low. So it'd be 100 versus the 1. 100 versus the 1. Huh. 100 versus the 1. And then technically could be 100 versus like the 2, or maybe 1 versus the 99. Generate all the subarrays like that. And then what? And then you have maybe the 100 versus the 3, or maybe 100 like versus 100, 99. Let's say it's like 531. So 100 to the 1, and then 100 to the 3, or 99 to the 1. 100 to the 3, that doesn't overlap with 100 to the 1. Or 99, well, 100 to the 3. So for each number, what I'm trying to get would be the range that it extends as the low value and the range that extends as the high value. The range that extends as the low value, the range that extends as the high value. And then like 1 would need to extend out to include the 100 in order for them to have any working subarrays that are low 1, high 100. Because here 1 extends as the low if you keep on going further to the, if you keep on extending the subarray further to the right, all the way to the end. And 100 extends to 1. The minimum has to be between those two. The minimum subarray has to be between those two. The range of the 1 needs to extend past where the 100 is. The range of the 100 needs to extend past where the 1 is. And then what? And then at that point, you push the right side to the minimum of the rightwards extension of 1 or 100. Because if it ends up to, like, let's say there's 200 at some point here, then 100 only extends up to the 200. Or if there's like a -5 here, even though there are negatives, it's technically not part of this array, but -5 would make this a lower minimum. So yeah, so it would stop at the minimum of a lower low on the right or a higher high. Same thing on this side as well. The 100 will extend as the top number up to this 1,000. That work? $100 to 1. Is that constant work in terms of figuring out how many subarrays work in that fashion? I think that might be constant work. I think that might be constant work. Then how many combinations can there be possibly n squared combinations? And I would need to make that in n log n time probably. Can I use a heap somehow? Can I pair the biggest versus the smallest? 100 to 1. 100 to 1. And then 100 to 3. $100 to 1 and then 100 to 3. Or 99 to 1. How would I calculate the number 100 to 1, 100 to 3, 100 to 5, 99 to 1, 99 to 3, 99 to 5. So maybe when I'm done with a particular combination, I try one less than that. Maybe be a heap. If only I knew how to process this. So if I for every value in the array get the range where it's low and high, sort those values, and then pair them up, like the highest high with the lowest low. 100 to 1. 99 to 1, 100 to 3. 100 to 1, 99. So 100 pushes onto the stack or onto the heap 199 and pushes onto the heap 100. Maybe the heap is the difference. 99, 98, 97. I'm always processing the biggest difference. And then 199 pushes onto the stack. 99, 3 or 1, and then the next one, the next index on the 99. Next thing after 99. Heap is going to grow pretty big. It's going to grow to n squared maybe. But then that'd be if I sort an n squared heap, that might be n squared log n, which is too slow. Hundred one, and then 199 or 100. One, which is, well, I guess I don't push 399 on a stack if 103 is still to be processed on the stack. So 101, 99, 103, 99, 1, maybe, I guess maybe it's possible I have multiple things that are duplicates on the stack. Because 99.3 would have also push, or 991 would also push, or whenever I process 103, it also push 993. So maybe there's duplicates that are causing it to be bigger, but then I could maybe handle the duplicates. Okay. Okay, so is it possible to generate the range of for each value in the array the range or the interval around that value where it is the low or the high in the interval. How would I do that? Let's say I want to just do it for the high. High interval. Let's say n is the length of it. Let's just do it times -1 times n for now. So for high interval, if I have a monotonic stack that is increasing 199, 100. Okay, let's do a small example. So 4251. So the high interval for 4 is going to be like from index 0 to index, let's say inclusive, so 1. 2 is going to be from index 1 to 1. 5 is going to be from index 0 to 3. And 1 would only be from index 3 to 3. So 4 is the biggest number from like 0 up to 1. 2 is the biggest number just for 1 to 1. 5 is the biggest number for everything. And 1 is just the biggest number from 1 to 1. And then, so how would I generate that? I maintain a monotonic stack of increasing values. So 4, 2 would pop out the 4. Can I even do it in one run? 4. If I have a monotonic increasing stack, 4, then 2, 2, 5, and then 1. If I had monotonic decreasing, 4, 4, 2, 5, 5, 1. Monotonic decreasing. 4, 4, then 2, 5 pops the 2, pops the 4. 4, I think it's monotonic decreasing. I want to say it's going to be like -1, -1. is the initial stack. And the stack has tuples that are the value in the index. Yeah. So it's like the value and the index. And I want to say maybe it should just be an empty array. For say every index k in range n, the value is nums at this. Okay, it's k. Nums is the value is nums at this index. So initially the stack is just 4. Actually, so it's monotonic decreasing. Yeah, it's fine. Yeah. So more than 2. Actually, maybe the value should start to be infinity here. Yeah. The backstop is infinity at the very front end of the monotonic decreasing, so there's like infinity, 4, 2, infinity. So I think it'd be something like, there's some code here, but it's like while the top or the back end of the stack, no, I guess it'd be the top of the stack, while the monotonic decreasing stat, the top of it, which is the last element of it, the value there is smaller than or smaller than equal to. I think this should be probably smaller than the current value. Pop that value. And there needs to be some code here. Handle, I want to say the left side of the, or the right side of the interval. Otherwise, skipping that to the more general case. So if there's infinity, then you push the 4. 4 would use whatever is the left side here as its farthest to the left that can go and be the highest. So I want to say, maybe I should make this a 2D array. Maybe I should just make this a 2D array. I wonder. I don't think this works. I think it's like -1 for that in range. this work, I wonder? It might be referencing the same array each time though. Let me double check. Oh, I should print that after. Just don't want to have the same reference to the same array each time. Okay. Okay, that's fine then. Handle the right side of the interval code. Okay, so where this thing ends up is the left side. So I think left side interval is adjacent to the previous high index. So I think it's going to be high at this index. The left side is going to be equal to the monodec. The last position for it, the right side. How far extends to the right, or the index that it is. I guess it'd be the index plus 1. High of that thing yeah, so like this thing is going to be for the current value, which is this value extends all the way to the previous value plus 1, the index of it that occurs. Otherwise, yeah, that's just how the monotonic decreasing deck works. It's gonna pop everything that's smaller than it. That's smaller than it before it. And that's how it handles the left side and handles the right side when it pops either here or after the array. So after the array, when it pops, I think I need to know what thing it's popping here. I guess I'll do value and index. I might not need to know value, to be honest. I just need to know the index. This previously popped thing. Oh, I also need to push this thing. Monodec. Monotonic decreasing, append the current value and the current index. So when it pops here, it's going to be high for this previous index I. The right side of it is going to equal the current index minus 1, because it doesn't include this current index. Right. and then it needs to, there will be a monodeck at the very end. So now everything here extends as far right as the last. So I think it's going to be while monodeck. I want to say I'm going to do something weird here. It's going to be +1 here. Okay, so while monodeck has anything, value and index pops from it. And high at this index, the right side of it is going to be inclusive up to n-1. Okay, and then let's go ahead and print let's say for every index in range n, let's go ahead and print out the high of this index 0 and the high of this index 1. Wow, I just all right. Not quite. 1, 1. I was hoping for 0, 1, 1, 1, 0, 3, 3, 3. 1 to 1. Yeah, this is pretty far from the correct answer. 4, 4. So it starts out with infinity -1. Pushes. Doesn't pop anything here. Shouldn't pop anything here. And then it appends for index 0. Should be 4, 0. And it should have set the left side of it to be oh, whoops, this is the wrong order. Whoops. Oh, whoopsie. Is that right? 0, 1. 0, 1, 1, 1, 0, 3, 3, 3. Okay. All right, that is correct. That is the intervals where each number is the highest. Okay, so then I need to do the low one. I guess that one should probably be monotonic increasing stack. Very similar. So let's go ahead and just do the quick verification of how this should look. So for 4251, if I do monotonic, I'm going to assume this should be monotonic increasing. So it probably should be like -infinity4, -infinity2, -infinity2, 5, and then -infinity1. And if this is the high intervals, then the low intervals should be 4 is going to be the lowest from 0 to 0. 2 is going to be lowest from 0 all the way to 2. 5 is low from 2 to 2. And 1 is lowest from 0 to 3. Okay. So the same thing when it pushes it, the adjacent spot in the stack is going to give it the left bound, and when it pops it, that's the right bound of the interval, of the low interval. So this is the monotonic decreasing, this is the monotonic increasing. Monotonic increasing stack with value index for every index in range n. Values nums at this index, while the monotonic increasing last value is bigger than pop. And then this should handle the left side. I'll figure that out afterwards. And the low interval. I'll just do the same thing, -1, -1 for everything in range n-1, n+1. Low at this index at 0. Left bound is the mono increasing. The last one, index +1. And then monotonic increasing appends the current value and index. And then this is low of the index, the n value for it is equal to index -1. And then while there is a mono increasing deck value, I guess I just need another index. And low at this index, the n value for it is n-1. Alright, and then let's go ahead and just print out this to make sure this is working. Okay, so should be 00022203. 00022203. Okay. Alright, so I have my intervals for each element. God, holy cow. How odd. I have my intervals for things. Now I just need to actually do the part where it combines the information. probably needs to be sorted. If it needs to be sorted, I don't think I can sort arrays, can I? Mono. Mono increase dot sort. This thing doesn't quite have enough information. It would need to have the value again. Yeah. Mono increase. Oh, it's empty right now. I was thinking with the high dot sort. Actually, yeah, this is, I think it should be the high and low. Does it sort? Okay, it does sort. Okay, I'm thinking. Probably want to have the information about the value in the high thing here. Then I can't have n+1. Or can I? Yes. If I said that the nums appends infinity here, or should append negative infinity here. Let's just say appends infinity. Maybe this tuple now becomes nums at index, let's say I, for every I in range to n+1. This is a little hacky. Hacks upon hacks. So these now are the low and the high, or the second index 1, index 2, or the start and end of the intervals. So index value compares to the monotonic decreasing value, and I think this should be the ending index, and this should be the starting index. and this should be an ending index. So this should be the ending index, starting index, ending index. And I kind of want to remove the infinity before I sort, if possible. If possible. Probably just pop before I sort for both the low and the high. That should be nums at I. Alright, so the high value 5 is from 0, 3, 4 is from 0 to 1, 2 is from 1, 1, 1 is from 3, 3. The low values 1 is from 0, 3, 2 is from 0, 2, 4 is from 0, 0, 5 is from 2, 2. Okay. That is what I wanted. I'm not sure if I want these to be sorted increasing all the time. Probably remove some of these comments. Yeah. Okay. Now comes the hard part. So it's the construction of the high and low quantities and seeing if there's overlaps. I feel like this is this strictly going to be wrong the way I'm doing this right now? Because am I just going through all the possibilities? If technically it's n squared possibilities. So what's the worst case scenario? Like the worst case scenario would be h high intervals. Well, maybe it looks something like this. Like maybe 3, 2, 1. Maybe 5, 4, 3, 2, 1. And then 100. 99. If I stick the lowest and the highest next to each other, stick the lowest and the highest next to each other. So it needs to be needs to be 1 to 100. Technically, this pretty much includes every subarray after 100 and before 1. Oh my god. Alright, I think it's time. It is time to go to bed. I think I can almost sense that I'm close. But I think I need to sleep.